Hello everyone, here the question says a current of 1 ampere through a coil of inductance 200 millihenry is increasing at a rate of 0.5 ampere per second. It is going to be di by dt. di by dt, yes, ampere per unit second. So the energy stored in the inductor per second. So they are asked du by dt is equal to du by dt is equal to question mark, right? That to know that we need to we need the derivation of the formula. So first of all, that formula is begins with psi is equal to minus L di by dt. So this is actual formula of psi in an inductor. Okay, now this psi is nothing but is equal to IR. Okay, it is equal to V, potential. EMF is nothing but the potential difference which is provided here. So from we know that work done is equal to V charge Q, multiples of charge Q, product of charge Q. Okay, V product to charge Q. So now V can be written as, from this equation, so V can be written as work done by charge Q. So I'm just doing this derivative. Okay, so this V is said to be psi here. Yes, so we know that, right? So psi can be written as V. So V is going to equal to minus L di by dt. So I'm just continuing the right hand side. So instead of V you can able to write dw by dq. So d I will be writing instead of w is the work done actually. Here I am going to write as u. It is also going to be states as work done. dq, which is going to equal to minus inductance di by dt. Okay, as continuing it, so multiplying dq on both sides, so du can be written as is equal to minus inductance di by dt, by dt into dq. So both the values are is going to be almost similar. So there is no any other dq, that is charge. Q is represent the charge present in the inductor. So nothing, there is no any, none of them is going to be present here. So by dividing dt on both sides from here, dt on both sides, dt on both sides, we get dq by dt is going to be equal to the current flow in a conductor is going to be the charge per the rate of change of charge in a perfect area of cross section of the wire is going to be the current flow. Okay, dq by dt. So I'm just substituting I here. For that I'm going to move into the next page. Finally we stopped our equation in du by dt is equal to minus inductance into di by dt by dt into dq. So here dividing dt on both sides I'm just doing here. So dq by dt can be written as I. So I'm just converting this thing. Du by dt is equal to minus inductance. Okay, I, this dq by dt is written as I di by dt. Understood? Okay, this is very simple, very simple. You can able to write it. Okay, so the given values are in the question inductance. So inductance is given here. Okay, this is L, right, and this is going to be the current I. So just doing capital I. This is di by dt, but we have to find du by dt. Everything is perfectly alright, perfectly matches with this equation. So I'm just substituting these values here. We have to find du by dt. our aim is to find du by dt is going to be the inductance into the current flow into the rate of change of current flow in the coil. So now to find it, just substituting the values given in the equation, the inductance which is provided in the equation is 200 millihenry. 200 milli. Okay, this is going to be 200 milli refers to 10 power minus 3, we know that, right? Milli into the current flows, yes, where it is current flows is going to be 1 ampere right here, 1 ampere. Okay, moving to the next page, 1 ampere, substituting 1 here, and di by dt, change of current, rate of change of current is 0.5. So 0.5 written as this, 0.5 is written there. So this is the value you have to find du by dt. So we know that 1 by 2 is going to be equal to 0.5. Then 0.5 is equal to 1 by 2. So you can able to write 1 by 2 can be 0.5. So 0.5 can be written as 1 by 2. So while dividing 2, yes, 0 point, when you keep 0 point here, 10 5s are, yes, 10. Finally 0 is going to be the, so when you divide like this you can able to get this. Okay, so even it can be written as like this, right? Now the du, the value we have to find is du by dt is going to be equal to 200. Instead of writing 200, I am just writing 2 into 10 square into 10 power minus 3, which is milli, right? That's why to convert into the SI unit we are doing this one. We cannot able to this is not necessary to write 1 here. Okay, okay, 0.5 is written as 1 by 2 here, 0.5 is written as 1 by 2 here, right here. And now simply you can able to cancel it. The final value, that is du by dt, is going to be equal to, so from this the remaining is this two things, that is 10 square into 10 power minus 3. So from a power m into a power n, we know that a power m into, yes, I'm just rewriting that thing. So a power m into a power n is equal to a power m plus n. Okay, this is the actual formula right here. So we are going to substitute this thing in the same thing. A is going to be 10 here and power m is going to be 2. 2 minus 3 is going to be minus 1. 10 power minus 1, which is going to be equal to 1 by 10 is 0.1 is the correct answer for this question. 0.1, where it is 0.1 is the answer for this question. Yes, option A, no. Option C, option C, 0. Sorry, option, not option C. Option D is the correct answer for this question.